We're going to look at radian measures today. A radian is actually just another unit to measure angles. So normally we measure angles in degrees. Now we'll use radians. Okay, kind of like Celsius and Fahrenheit. They both measure the same thing, but they're just different units. Okay, so it's another unit to measure angles. And it's found because it's the angle made when we take the radius and wrap it around the circle. So just kind of put that in perspective. So this is my radius of the circle. It's half the circle, half the diameter. So here's just a piece of string that represents the radius. If I were to take that piece of string and just wrap it around the circle, that distance, so that would be right here. So if I were to make that angle, that is, that's 1 radian of a circle. Okay, so normally we would have it in degrees, but if I take the radius, wrap it around, that's 1 radian on that circle. Okay, and then this right here is S, which is the arc length, which you've probably done a little bit with arc lengths in geometry. And then we have our central angle. So the central angle is the angle that has its vertex at the center of the circle, okay, which should make sense because it's in the center. Okay, so it's an angle that has its vertex at the center. Of a circle. Okay, so we use degrees in everyday life, but as far as like a mathematician's life goes, radians are just more pure, so they really like to use it in mathematics. You can also compare it to percents and decimals, right? So I can write a number as a percent, and then I can also write it as a decimal, so it's like 2 equivalent ways to write the same thing. So that's kind of how angles and degrees work. So I kind of want to, let's go over this. So we already did our unit circle, and our unit circle, so unit circle has a radius of 1. Okay, that's the point of the unit circle. Okay, so if that has a radius of 1, the formula for the circumference of a circle, so the circumference would be the outside of the circle, so that is 2 pi r. Okay, and since we know the unit circle has a radius of 1, I can put that in here, so c equals 2 pi times 1, and 1 times anything is just itself, so the circumference is going to equal 2 pi. Okay, and we know that the whole circumference, let's say I travel around the whole circle. How many degrees is it if I travel around the whole circle? Well, it's 360 degrees is the circumference, and that can equal 2 pi. So pi actually equals 180. Okay. So that's going to be important for when we're converting, just knowing that pi is the same thing as 180. So radians, we can tell radians and degrees apart because radians are always written in terms of pi. So if you see the pi symbol, that's a radian. So let's convert. We have, so x degrees, and then we'll do pi over 180 if we're going from degrees to radians, where x is some angle in degrees. Okay, so when we are doing this, we have 60 degrees. Okay, and I'd like to convert that to radians. So this is relatively easy. I'm going to just replace it. So 60 pi over 180 is how we convert it. But what we need to do is we always need to reduce this fraction. So if you actually type 60 divided by 180 and do, the math button, and then notice FRAC. So if you hit enter, what that's going to do is it's going to reduce it as a fraction. So you have 1 over 3, but we keep that pi in there. So it's 1 pi over 3, and we don't really need that 1, so we can get rid of it. So it's just pi over 3. Okay, so 60 degrees actually converts to pi over 3 radians. Okay, and you're going to go in your calculator again, type the fraction in, 60 divided by 180, hit math, and then the fraction button, okay? Or you can do that math in your head. So let's try one of those on our own. Try converting 210 degrees to radians. So we will take 210 pi over 180 in the calculator. I'm going to type 210 divided by 180, math, fraction, and that gives me 7 over 6. So this simplifies to 7 pi over 6. Okay. Let's go the other way. So if I'm converting from radians to degrees, so I'm going to give you it in radians, so 3 pi over 4. Okay. So essentially what we want to do, if I'm going from degrees to radians, I kind of multiply it by pi over 180. So if we're going the other way, we are going to multiply it by 180 over pi. Okay, so then what will always end up happening is these pi's will cancel out, and then I have 3 times 180 over 4. So 3 times 180 is 540 over 4, which equals 135 degrees. Okay, so that's one way to do it. Another way to do it is, so we'll put or, so we have 3 pi over 4. Right here we know that pi is the same thing as 180 degrees. So I can just put 180 degrees in here over 4. Okay, which would get us the same thing, 135 degrees. So there's 2 ways you can do this. If you want to keep it consistent with the front where you're doing pi over 180 to go from degrees to radians, and then you just flip it 180 over pi to go the opposite way, that's fine. Or you'll notice what ends up happening is these pi's will always cancel out, and then we'll always get that kind of like we're plugging in 180 for pi anyway. Okay, so there is, if we're given though, if we don't have a pi symbol, so 14.5 radians. So sometimes we'll see radians written like that, and you will always see this label after it if you don't see the pi, because then we don't really know what it is if we don't see the word radians. So this one we do have to do it by 180 over pi. So I take 14.5 times 180 divided by pi, but now we're going to use the actual value of pi. So 14.5 times 180 is 2,610 divided by pi, and then in your calculator we'll do 2610 divided by, and then the pi sign is on top of the caret. So we'll hit second, pi, and then we'll get 830.79 degrees. Okay, so this equals 830.79 degrees. All right, so try the next one on your own. 7 pi over 5, and then 10 radians. Alright, So for A, we can multiply by 180 over pi, or we can plug 180 in for pi. Either way, we get 1260 over 5, which is 252 degrees. And then if I have 10 radians, I'm going to multiply that by 180 over pi, 1800 over pi, 572.96 degrees. Okay? So let's move on to example 3. Let's put it with some trig functions. So if I have sine of pi over 3, okay, what we need to do is convert the radians to degrees first. Okay? So convert radians to degrees first. So we know that pi is 180, so I can just say sine of 180 over 3. And that equals sine of 60. Okay, and then we can go to our unit circle. So here's our unit circle, here's 60 degrees. We know it's always cosine and then sine. So sine of 60 degrees is root 3 over 2. And we're done. Okay, so let's try another one on our own. Cosine of pi over 4. Okay, so evaluate that exactly. So we'll do cosine of 180 over 4, which equals cosine of 45. I go to 45 degrees. They're both the same. Cosine is the x value, so I'll take the first one, square root of 2 over 2, and we're done. Okay, so what I'd like you to do for homework is page 138, numbers 18 to 21, 32 to 44, 51 to 73 odd. Okay, and then please reach out if you guys have any questions. Have a great day.